Let's talk about the first steps of data analysis in R. We will walk through essential tasks, including reading data files, inspecting data, and manipulating data, all using features available in base R. The first step in data analysis is to import your dataset into R. But before we do that, let's first export an existing dataset to a file format that we'll later import. Air quality is a built-in dataset in R. Use the data function to load the built-in dataset, and then we write it out into a file using the write.csv function. Use the row.names equals false argument to disable exporting the row names, which will just be 1, 2, 3, 4, and so on in this case. Now we have a comma delimited file that we can import. Use the function read.csv to read a comma delimited file. You can use the more general function read.table for more options. For example, you can specify the separator to be comma in this case, but for tab delimited files, specify \t. I used header equals true here to indicate that the first row in the file contains the column names. This argument is true by default in read.csv, but false by default in read.table. Here I'm giving just the file name because the file is in the current working directory. You can check your current working directory using the getWD function. If a data file is not in your current working directory, you can give the absolute or full path to the file, or the relative path, which is relative to the current working directory. After importing your data, it's essential to inspect it first to understand its structure and contents, and to make sure it's been imported correctly. Some data tables are huge, so you can use the head and tail functions to show just a few lines. Use the n argument to specify the number of lines to be shown. You can use the structure and summary functions to get a quick overview of the data frame. The structure function shows that there are 150 rows and 6 columns, what the names of the columns are, and the data types of the columns that are automatically determined when reading the file. The summary function gives descriptive statistics for each column. Once your data is properly read into a data frame, there are many different things you can do to further process your data, including changing data types, adding or removing columns or rows, reformatting, and summarizing your data. When using a data frame with the is.na function, there will be a true or false value returned for each cell of the data frame. The sum function forces all trues into ones and falses into zeros. And the sum is 44, giving us a quick glance of how many missing values there are in our data frame. You can choose to remove entire rows with any missing values in them using the na.omit function. You can also choose to replace missing values. Putting the matrix of true or false as indices in square brackets of the data frame would select those cells of the data frame that correspond to the value true, and you can assign to these cells a replacement value. I don't want to replace anything in my case, so I'm just assigning NA for demonstration. As I mentioned before, R automatically determines the data types of the columns when reading the data file. There will be cases where you would need to change the data type. Here, the temperature column is of the integer data type. But because temperature can have decimals, I want to change the column to the numeric data type using the as.numeric function. There is an as.datatype function for each data type. There might be instances where you have rows with identical values that you want to remove. You can use the duplicated function to check for duplicated rows, which returns a true or false value for each row. Putting this logical vector as the row index in the square brackets will allow you to select the rows you want. So here, all columns are selected because there isn't an index specified after the comma, and only those rows that are not duplicated are selected.